This is Pre-Calculus A, Unit 3, Lesson 2, Even and Odd Functions. So we're going to determine or distinguish the definitions of these things and tell the difference between them. You're to determine whether a function is even, odd, or neither. There's typically three choices because neither is a choice. All right, let's define even first. An even function is a function such that when I input a negative value, it's the same as inputting a positive value. F of negative x equals f of positive x. For example, if I input negative 2 and get out 3, I must input positive 2 and get out 3. If I input negative 4 and get out 1, I must input positive 4 and get out 1. Okay? It doesn't matter whether I've input a negative or a positive, the answer is the same. Okay? All right? And here's an example of an even function. Sine x, or not sine x, sine is odd. Cosine x. Cosine of x is even because cosine of negative x equals cosine of positive x. And this works for no matter any x's you choose. So the cosine of pi over 2 is equal to the cosine of negative pi over 2. Both of them give you an answer of 0. Cosine of pi over 4 equals cosine of negative pi over 4 equals root 2 over 2. Okay. Now let's look at what it looks like graphically. It's going to be striking here, pictorially, what happens. All right, so des most, not des least, but des most. All right, and let's graph these here. And I want you to notice something about even functions. So I'm going to start with the table here. So negative 2, 3, 2, 3. Okay. Negative 4, 1, 4, 1. Notice there's this reflexive or reflection going on, a vertical symmetry, so to speak. If we graph the line x equals 0, which is equivalent to the y-axis, that line splits this in half. They are mirror images of each other. They're copies of each other on either side. That's more importantly, if we graph y equals cosine x, we get this same symmetry. That vertical line divides it evenly. It's the same on the right side as it is on the left. It's like a folded book, right? Or the wings of a butterfly. So graphically, even functions have y-axis symmetry, or symmetry with a line x equals 0. Okay? But by definition, and if you're asked to prove or demonstrate something is even, you need to demonstrate or prove that inputting a negative or a positive always gives you the same answer. Okay? Let's look now at odd functions. Odd functions. A function is odd if inputting a negative, if inputting the opposite or negative of something causes the function value to be opposite of what it is, of it, or negative, right? And so if I input a negative value, I get out a negative value. Or if I input a negative value, I get out a negative value. If I input a positive value, I get out a positive value. So here's what it means in terms of numbers. If I input a negative 2 and get out 3, then inputting a positive 2 should give me a negative 3. Okay? Switching the sign on the x necessarily switches the sign on the y. Inputting a negative 4 and getting out 1, then if that's the case, if I input a positive 4, I should get out a negative 1. Switching the sign on the x switches the sign on the output on the y as well. An example of an odd function is sine x, because sine of negative x is negative sine x. Okay? Sine of pi over 4, sine of pi over 4 is root 2 over 2. Sine of negative pi over 4 is negative root 2 over 2. Changing the sign, changing the sign on the x changes the sign on the output. Okay? And that is true for all x values you can input into sine. Okay, let's demonstrate what that looks like on a graph. Okay, instead of a y-axis symmetry, what have we got? We've got -2, 3, -2, -3. Or +2, -3, +2, -3. Changing the sign on the x changes the sign on the y. -4, 1 becomes 4, -1. Okay, so now instead of 4, -1 to -2, I've got something wrong here. 2, -2, 3, 2, -3. There we go. Oh, what just happened? There we are. 2, -3. There we go. All right, and now you see there's some symmetry, but it's symmetry of rotation. Imagine putting a pin in 0, 0 and spinning the whole graph 180 degrees like a propeller or like a pinwheel. Okay, and let's graph it here. Y equals sine x. Y equals sine x. Okay, again, imagine putting a pinwheel in pin in 0, 0 and spinning the graph. Okay, when you spin the graph, you get the same shape. Here, let me demonstrate with the computer a little bit. So I'm going to grab a screenshot, and we're going to spin it. Okay, so let's put that right down, well, right in the middle of the screen. Okay, so it looks like that if I spin it 180 degrees. Okay, 180 degrees, it looks the same. Spin it. There's the way it looked originally. Spin it 180 degrees, and it looks the same. So it has, we call this point symmetry. Point symmetry. Okay, so that's the definition of even and odd. You can recognize it in a graph if it has point symmetry with the origin, across 180 degree point symmetry, then it is odd. If it has y-axis symmetry, that is butterfly type symmetry with the y-axis, then it is even. And if it does not have either of those, it is neither. But if you're asked to prove it, you need to use these definitions. F of -x equals f of x. And then for odd, f of -x equals -f of x. All right, so hopefully that makes sense.